Howdy, howdy. This is Mr. Potter. In our previous lessons, we've been talking about this fraction class that we've developed, and we've created a couple of constructors for our fraction class, and we've also created some accessors for our fraction class. But one of the issues that we have is the way that we've established this fraction class. It's immutable. In other words, it really can't be changed. What we really want is we want something that's dynamic, something that can be changed, because our needs may change. And so what we're going to do is we're going to write some code called mutators. So immediately after the toString method that we did, I want to create some mutators. And what a mutator does is it changes the state variable. Remember that we had two state variables for our fraction class. We had a numerator and a denominator, and those were variables that we kept track of as we went. These two state variables pretty much define our fraction, because no matter what, we're always going to have a numerator, we're always going to have a denominator, even if that denominator is 1. So, I want to talk about things that can mutate this, things that can change the fraction. So the first thing I'm going to do is I'm going to create a method called setDenominator. Now, again, the thing is, my denominator is a private instance variable. So I have to control how they can change it. So this method, if I want people to be able to change my denominator, is going to have to be a public method. And I'm not going to get any information out of this. All that the user is going to do is they're going to specify some denominator. So that's going to be the parameter int new denominator. And then we're going to assign it. So if we're not going to return a type, like we're not going to return an int or a double or a string, then what we do is we specify that we're not going to return anything. We have a return type as void. And so what void really means is that we're not going to be returning any data to the user. In other words, most of our mutators tend to be void methods, whereas most of our accessors tend to have a type that they return. We're just performing a task. We're not getting a value out of this. As a matter of fact, they're specifying the value that we're going to be using. Now, for the code for our mutator, we're essentially allowing them to tell us what the new denominator will be. So, in other words, I'm going to set my private instance variable denominator and set that equal to the new denominator that they specify. So in other words, they'll be able to change the denominator on the fly as long as they use our set denominator method. And I can do the exact same thing for the exact same thing for the set numerator. So I'm going to do public void set numerator, and they're going to give us a new numerator to work with. And we're going to set our numerator equal to the new numerator. So it's relatively straightforward how we're doing this. We're taking our instance variable, numerator, and assigning it to what they pass us in the parentheses, our new numerator. So let me go ahead and compile this real quick. I'm going to jump over to our fraction runner. Remember, we've been dealing with our fractions for a while. Right now, we have pi being 22 over 7. I'm going to go ahead and say, let's do this. Let's do pi dot set numerator, and I'm going to set my numerator to 314, and I'm going to do pi dot set denominator to 100. So now our estimate of pi is 314 out of 100, or 3.14. So now if I do system.out.println pi, as long as I spell system correctly, and run this, says I put a semicolon where it belongs. If I run this, it should change pi to this new fraction, 314 out of 100. And of course, I can do system.out.println pi.getValue. And it should reflect our new value, which is 3.14. So we've got mutators, things that change the state variables. There's some other methods that we're going to want to deal with here. And these other methods are ways that we can manipulate fractions. Of course, these being mathematical constructs, there are things that we can do with them, which is add, subtract, multiply, and divide. But what we're going to do in this situation is we're going to make class variables or static variables. And the idea is that I want to be able to say a fraction sum is equal to fraction dot add, and I can add pi and better pi. In other words, I'm going to add the fraction, ask the fraction class to add these two fractions together and store that result in a new fraction, which I'll call sum. So in order to do this, instead of to have the object have a method, but to have the class itself have a method, there's one keyword that we use, and it's a keyword we've actually seen before. It's static. And we've seen static whenever we have our public static void main. That's primarily where we see it. But every time that we did math.square root or math.round or math.pow, those were all static methods as well. And they look exactly the same as our normal returns. So what's going to happen is I'm going to create a public static method called add. And my method is going to expect a fraction, let's call it f1, and it's going to expect another fraction, which I'm going to call f2. And out of this, I should get a fraction. So my return type is fraction. So I'm going to have two parameters, the first and second fraction, my add-ins. And I'm going to get a result out of this that is also a fraction. So remember, to add fractions, the first thing I have to do is figure out my common denominator. And I'm going to say my common denominator is equal to f1 dot denominator. But of course I need to access it, so it's going to have to be get denominator. Times f2 dot get denominator. So this is how we've gotten our common denominator, basically by multiplying the two denominators together. And then to get my numerator, I'm going to have to multiply the denominator of one fraction times the numerator of the other and add those products together. So int new numerator gets f1 dot get denominator times f2 dot get numerator and I'm going to add that to f2 dot get denominator plus f2 dot f1 dot get numerator. And then once I've created this numerator and this denominator, I want to go ahead and create a new fraction. So I'm going to say new fraction using the new numerator and the common denominator. And I want to return it. So I'm going to return my new fraction with the new numerator and the common denominator. So let's compile this, make sure it works. And so what I can do is I can tell this to say a fraction sum gets fraction dot add with pi and better pi. So I can system dot out dot print line sum dot get value. Now keep in mind we're talking about approximations for pi. So if I take 3.14 plus 3.14, I should get 6.28 something. So what did I do wrong? Sum dot get value, of course. Can't type, it's too late at night. Get value. Yes, we all make mistakes like this. Caps lock is on. That's what it is. And so that's not a good answer. Should be getting 3.17. Let's see. Did I do something wrong over here? Let's see. Should be f1 dot get denominator times f2 dot get denominator. That's my new common denominator. And f1 dot get denominator times f2 dot get numerator plus f2 times get denominator plus f1 dot times. That's the problem. Helps if you know mathematics. So we'll go ahead and compile this and run this. And I should get something really close to 2 pi, 6.28. Now, of course, it's going to be a little bit off because we're using pretty poor estimates of pi. I mean, here we only have 3.14, which we're adding to our really good estimate of pi. And so notice everything after this decimal place just kind of matches what we have up here. And the other thing to notice is that it's not a perfect match. We've got 1592 ... So some other things are happening here. So let's do one more of these static methods. I'll leave the other two for you to take care of. So let's talk about a static multiply method. So I'm going to do public static fraction multiply with fraction f1 fraction f2, and then remember to multiply fractions, all we do is we multiply the numerators and we multiply the denominators. So int new numerator is going to be equal to f1 dot get numerator times f2 dot get numerator and int new denominator is going to get f1 dot get denominator times f2 dot get denominator, and then we're going to return a new fraction of type new numerator and new denominator. And so all I'm doing is I'm multiplying the numerators together, storing them in numerator, multiplying the denominators together and storing them in denominator, and creating a new fraction. As long as I spelled everything correctly, then I should be able to come over here and say a fraction product, which is equal to fraction dot multiply pi and better pi. Then I can system dot out dot print line product dot get value, and if I'm taking 3.14 times 3.14, I should be getting about 10 point something, as soon as I remember to close my parentheses. And we get 9.864. So we have multiplied these together. Now, in our next video, what we're going to talk about is how to reduce these things, because this is pretty awkward with what we've got. I'm taking these numbers and I'm multiplying them. If I do system.out.println just product, just to see what that fraction looks like, this is what I'm going to get. I'm going to get 111,470 divided by 11,300. And I know that that reduces. So what we're going to talk about in our next video is how do we actually go about reducing these. These are helper functions. We don't necessarily want someone else to come along and reduce us, but we would like it if we ever did some addition, subtraction, multiplication, or division, that we'd be able to reduce that sum or difference or product or quotient. So once again, this is Mr. Potter. Thank you for watching. Have a great day.